Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Aaron Newcomb joins me. We're going to talk about YaCy, your personal web search engine. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CacheFly.com.
This is FLOSS Weekly with Randall Schwartz and Aaron Newcomb. Episode 267, recorded October 2nd, 2013. YaCy. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at Stonehenge.com, bringing to you as often as I can the movers, the shakers, the big projects, little projects, projects you might not have heard of at all, projects you might be using every day and not knowing about it. As often I am joined by a co-host this week, none other than Aaron Newcomb. Welcome back to the show.
Hey, Randall, good to be here.
Hey, good. And where are you speaking? Oh, I bet I know where you're speaking to us from.
Yeah, can you guess by the background? I don't know.
I'm thinking it's looking like the Twit Brick House.
That's right, yeah. It's very early here on the West Coast, but I got up early and drove in like crazy to Petaluma, and here I am.
Yeah, and I walked across the whole street here very early this morning, and a little too early. I could have excused a couple hours of sleep, but we're doing the show anyway. It's just going to happen. It's called right. Cool. We have a great guest today. His name is Michael Christen. I hope I pronounced that right. And he's going to talk to us about, I think it's YaCy, which is a search engine software. It's for making intranet portals and not internet portals, but internet searches. So you can actually search your local data storage, but it's also for empowering you to search the whole internet as well. What do you think of this so far?
I'd never heard of this before, so this is actually good, but it looks really good for enterprises, especially, like you say, people that want to set up their own Google-like search engine for their internal website. It looks like a really good project and easy to implement. I know a lot of people are selling these services, so it'll be good to find out if they're monetizing this somehow or something. But it looks like it would be really useful for companies as they start to get beyond the 50 employee size, and all of a sudden they have all this stuff all over the place, and
everybody's got data.
They need to
Everybody's
index
got data.
it. So
yeah, definitely. Well, let's go ahead and bring Michael Christen on. Go ahead. Welcome to the show.
Hello and good morning. I'm so happy to be here. This is a great honor to be in your show. And I'm looking forward to your questions. You already said so many things what YaCy is and what you can do with it. You didn't mention the peer-to-peer functionality, which was the beginning of the story, but we can do enterprise solutions.
Very good. So give us a 30,000-foot view. What is YaCy about, and what problem does it solve?
So in the beginning, it was just a project to have fun. I wanted to write an HTTP proxy. That was everything. And then it started to get wild in some way. So there was the crazy idea to create a search engine based on proxy scraping. But it quickly became the idea to do something in a peer-to-peer style and create a large-scale peer-to-peer search engine. So the idea is that you have the software that someone who has a large search engine, like Google, but it's not necessarily Google. And you imagine you take out the software out of their data center and you put it into your computer at home. And then you run it, it connects to all the other users, and it creates a network of search engines. And it distributes the search index, and therefore creates another large-scale search engine. But you can run this also for your own and create your own search portal.
So essentially what I'm doing is I'm building my own Google, right? So I can type in search terms into this and back come results. So how does it decide what websites to crawl?
Right, you can think of it like your own Google, and you need all the tools that maybe Google have. I don't like to speak too much about Google because it's not really about a competition with Google. It's just a great idea. The Google people had this, and we started a little bit later. But if you want to create your own search engine, then you need to put in all the web pages. That's most people don't understand. how a search engine works. You need to load all the web pages, and that's also integrated into YaCy. You need a web crawler, for example. You can do other things to get all the web pages, but you start, it's easy. You start by typing in one single web page, and then a crawler loads that web page and takes all the visible text out of it and puts it into a search index. And then it takes all the links inside this document and loads them as well. And this is starting again, and it's loading all the pages which are embedded in the next level of documents, and so on. You can get a lot of documents into your search index doing this, many thousands very quickly. And you need to have some idea what's valuable for your own search. So you can start to take your bookmarks, or you can have a specific topic. Most people who run YaCy have IT technology as their topic, which they put in. So this is where YaCy is strong on all the IT topics, and Linux and free software and so on. But it starts to get into other areas as well.
So this is something that would run on a server, or would it run on a collection of servers? I mean, Google's got millions of servers, but do I need millions of servers to make a reasonable scrape of the internet?
It runs on your own home computer, so you don't need a server somewhere else. You just put it on your home computer, and so it doesn't need any more resources than you actually have. And you can run it in different styles. You can just power it up if you want it, or you can leave it on to support the search community, so it can respond to the search requests of the other people.
Okay, so I would use it as I would run it on my home computer to support other people also doing searches. So how does the searches get distributed and shared back and forth? What kind of protocol is being used there?
Most people know file sharing and file sharing protocols. What we do is something which can be seen as a similar technology. While file sharing is about sharing parts of a file, we share parts of a search index. So the distribution of a search index has a mathematical model. We use a distributed hash table on terms, so we can identify specific peers which are inside this network, and they can store specific terms which are searchable there. We do this with redundancy, with failover technologies, and with scalability. So the whole network it creates what is called a search cluster. Search cluster scales with the number of documents and with the number of search requests. So you can really imagine what's inside of a data center as a search cluster is now distributed to the home computers.
So does that speed up access as well? I mean, do all the nodes? So first of all, let's just clarify, make sure I understand. So what we're doing is we're creating a public, so to speak, it doesn't have to be public, but a distributed search cluster across potentially personal computers. Basically anywhere on the internet, right? I mean, you don't have to be located on the same ISP or anything like that, right? It's more like, you know, the SETI, what is the SETI project? Search at Home or SETI at Home or something. It's more like that, right? Where you're completely distributed, and or DNS might be another good example, right? Where this is distributed across the internet, or could be distributed across the internet. You have multiple computers doing parts of the work, and in the end, you have one big search engine that everyone can access. Is that correct?
It's almost correct. While SETI at Home is about distributed computation, YaCy is about distributed storage. These are not completely the same things, and you need different resources. And it's also a little bit about bandwidth, and it's about response time. So what we need is to have a fast search is also a fast response time to the client, while SETI at Home doesn't rely on a fast response time. It just relies on the CPU power which you have. So if you compete YaCy with something like Google, again to mention Google, we don't have a network which is so fast to, how the peers are connected in a very fast way. We have only peers which are connected with DSL connections or slower or whatever you have. So it's not a construction which can compete to a search engine which is in a data center, but you can put YaCy in a data center and do this as well.
Right.
But as an home application, it doesn't scale better as something which you use in a centralized way, because it's made on home computers, and maybe these home computers are doing something else at the same time.
And maybe I'm running BitTorrent, or maybe I'm playing Grand Theft Auto 5, which just came out, or something like that. And so all of those things are going to be dependent on the availability of each member of the cluster, which may or may not be busy doing something else. So I want to get a good understanding of how this is actually installed and how it's used. So 2 parts here. So first of all, if I want to get started, how do I get started? Is there some software that I download? Does it run on Linux, Windows, and Mac? What's the process like for me to get started on this? I'd say I just want to set up a single node to start with, and then maybe I'll get my friends to help me out or something.
It's very easy to be installed. If you can install a text editor, you can install YaCy as well. You just download a package, and it's available for Windows, for macOS, and for Linux we have a tar file, or you can also have a Debian package. And you just decompress what you downloaded and then run a start script. And for some version, for macOS, it's like double-clicking the icon you downloaded. And it's very easy. What it does then is it starts a web server. Everything you do in web search is done in your browser. So it's a natural way to administrate your search engine inside of your browser. So all the administration parts are inside of this web application, which is started if you start YaCy. So it's easy to install. It's really easy. Just download, decompress, and start.
Okay, so now I think you're going where I was going. So now I want to add another node to the cluster. How does that work?
Yeah, most people, what you see first is that it opens automatically a search page, and it looks very familiar to what you know from a search page. It has a slot where you can put in some keywords, and you get search results then from the peer-to-peer network. So you don't need to do anything if you just want to do a web search using the YaCy peer-to-peer network. That's the first thing you see. You can use it right on. But if you want to start to put in data yourself, then you click on a menu link, and then you see a lot of options. And most people are very impressed of the many things you can do. And we need to teach them a little bit how search engine technology works, and they can explore it in the web interface and can see all the harvesting methods and so on. So I don't know exactly where to start there. Besides, the easiest thing to see and to do is just have a look at the peer-to-peer network. There's a visualization of this, and you can see that they are peers. They are sending, maybe they are starting right away to send your peer index fragments. Or if you started a search, then your own search index has accumulated some data, and it starts to distribute it again from its own. So this is done automatically, but the search gets better the more searches you do, because it all remembers all the web pages that other peers send to you, and it with each next search it uses this information again.
Right. So all the information gets distributed to all the nodes. Is that by default, or can you change that? And also, how much of a hit am I going to take on the storage aspect? How big do these things typically grow?
You will need some gigabytes of disk space, but at this time gigabytes is not a lot of data you need. You need a little bit of RAM. Memory is initially there's 600 megabytes initially used for YaCy, but you don't need it in the beginning. But you will very quickly acquire a lot of documents. After 1 day usage, you can reach 500,000 documents in your own index, and then you need some more resources to organize this information. It's not so much space you need on your disk. The space you need is only needed for the text data which is indexed. So if you extract the text from a web page and don't use the images and so on, then it's just some kilobytes you need for each web page. And then a search index has about a double time of that storage space.
So could I use this? Could I use this to set up my own internet archive then? So if I want to catalog certain sites for whatever reason, and I want to go back in time to see what they looked like, is that possible as well?
Yes, there's a web cache integrated, and below the search result, you know it from a Google search, there's a cache button, and you get the result from the cache, and that's also in YaCy as well. But it's only the latest version in the cache. So if you override it with a new version of the document, it's overwritten. It's not made for an archive version. But many people have this idea to use it this way. Maybe if the requests are stronger, we may put this functionality in. But you can have an archive, but just one version.
Yeah, that's what I was thinking. I'm just thinking like this would be perfect. If you did have that archive function, it would be great for newspapers or online media that wants to catalog, and keep track of these things as they change, so they can go back and say, oh, on such and such date, they said this. Because a lot of time that information, and this is why the Internet Archive exists, but they don't necessarily capture everything. A lot of times that information just disappears over time. That's one of the downsides of digital media as opposed to old media, where it's on a paper and it's on a micro file somewhere, and people can go back and access it. With digital media, that stuff disappears. So I would be really interested to see that feature. Okay, so let's shift gears now and talk about the client side. So let's say I've got my network set up. I'm pointing to a certain number of sites. Maybe I'm a scientist, or maybe I am in the media, and I have my own search engine to search the Wall Street Journal, the New York Times, all the papers, right? And that's all I want to search. And so I've got my own search engine set up to do that. From a client side, how do I access the search engine? It's
the search is running in your own web server. You can install this as well on a server in the internet and access it there. So the search is always available in the same interface where you do the administration. But you can put the information somewhere else as well, so you can access the search interface using an API. There are standards implemented in YaCy like OpenSearch. OpenSearch is an extension of RSS. And RSS is as a search result is actually very interesting because it gives you alerts, so you can have search results as alerts very easily if you just take the RSS result from the search. So the search interface is always there where you run YaCy. You can have it locally on your computer, or you can have it on a server in the internet.
So I would go to the website. I'm just trying to make sure I understand. So I would go to the website that's running on that YaCy spun up, right? I would go to that website, and then I would have a search bar, and I could just type it in there. Could I also do the same thing from my own, from within the browser? I'm thinking like, how on browsers you can say, I want to use Google's as for search results, or I want to use Yahoo for search results. Could I also specify I want to use this particular server for search results? I think you can, at least in Chrome. I can specify, I can create my own entry in the search, which search engines to use. So I'm assuming you could do that as well.
What you mean is the search slot in the top right corner of Firefox, for example.
Yes, exactly, right? Exactly.
The integration of this of a search engine inside of this slot is also done using OpenSearch. This is a description model. It describes you how a browser can access the search engine. And if you searched in YaCy only one time, then the browser remembers that there is a new search engine. And in this search field, there's an option button. And if you click on the option button, there's an option saying add new search engines. If you select this, then you get the YaCy peer you used then as an option, and you just click on it. And then it's integrated into your search bar in Firefox.
So how is this thing actually?
It's easy.
How is this thing actually distributing the challenge of searching for things? I mean, am I doing peer-to-peer also browsing through the crawled data, or is it all have to be on one system and then I crawl through that?
I don't know if I understand the question correctly. You at first need to load all the web pages to your own peer.
Okay, so in other words. Yeah, in other words, everything I want to search has to be on one system. Then it's not like somehow you're also distributing the work of crawling through or of indexing all the pages. That's all happens on one machine.
It usually happens on one machine. There is an option to distribute the crawl you want to do to other peers as well. It's creating a list of URLs which you can provide to other peers, and other peers can come and say, I want to take part of this crawl. This is also functionality, but you need to switch it on to make it work. So not many people used it, and we thought we don't want to switch it on by default, because people don't know what happens if their YaCy peer starts from itself to load some web pages, and sometimes these pages are some web pages they don't want to load with their own internet account.
Sure.
So this option is there, but it's switched off by default.
Well, I understand the crawl is happening on multiple machines, but like, let's say I'm searching for Randall Schwartz, my name, right? So does that query go out to hundreds of machines, or just the machine that's closest to me, and it has to have an index of everything because that's the only place it's going to look?
There's a metric defined on the search terms, and this metric describes which other peers are to be accessed. So that means if you do a search for anything, it looks in your own search index, but it can compute specific other peers which should have the index. And these peers have the index because they had been used as a target for index distribution in advance of the search. So if you do a web crawl, you create your own search index, but your YaCy peer starts to distribute this information to other peers, to specific locations, which are then or can be searched by other peers because they know the same procedure where to store this information. So actually, your YaCy peer searches a lot of other peers, some 20 or 30, but these targets are computed by the terms you used. So these are the same targets which have been used for distribution.
So it wouldn't be true that every machine has exactly the same copy of the data. It's basically each machine sort of figures out how to have a portion of the data, and every machine knows how to figure out what other machines might have the more relevant data for a particular search.
Yes, the information is not copied in total. Every peer has their own information. It's the information which is specific to what the user put in, and it's specific to the distributed hash table position of the peer inside the YaCy network.
Okay.
So it gets a fraction of the other indexes.
And who designed all this? This sounds really actually fascinating. Is this leading technology, or is this something that like Google should be looking at you guys to figure out how to do this better?
No, it developed over the last about 9 years. It's almost 10 years that we started with the idea, or I started with the idea because I wanted to program an HTTP proxy. Okay. And when I talked in web forums, about the idea to create a search engine, then more people came in, and we started this discussion and planned what can be done, and how can it be done. So it's in a kind of fun. YaCy is not only a search engine; it has some more components which many people thought it's fun, maybe not so useful now. But it developed with more than 30 people who contributed to the codes in all these 9 years. And these are only people, about 30 people had been subscribed to we had an SVN archive, but we moved to Git recently. Mm-hmm. And in the last 2 years when we used Git, some more people came with merge requests, and I don't know how many contributions have been then there, but it's over 30. People send us code by email or translations and so on. So it was my idea, and the basic architecture of the peer-to-peer technology was what I designed. But we had so much discussion about it that it was a collaboration which created this technology.
And so when I went to the site, there's a site that you list that says, without having to actually download a client and get it started, you actually go and do a query. And I got a very different set of hits for my name than I would have gotten on Google. I'm wondering,
yes,
how complete are you searching the entire web with that particular portal? Or is it just because it happened to have a different ranking than, say, Google would have given it?
It's not because it has a different ranking. We actually need to learn a lot more about ranking, but this is a very strongly kept secret. Everyone who knows a lot about ranking keeps it for themselves. Mm-hmm. Every peer acquires different information. That's one reason, because one peer has a different search result for the same terms than another. Mm-hmm. And within the network position, when you do a search, then maybe some other peers answer more quickly than others. And this also influences the order of the results. Many peers don't respond within 5 seconds, so we just cut it off somewhere. And we just use the results which have been transmitted from the most peers within 1 or 2 seconds. So you don't need to wait very long for the results. Mm-hmm. But this kind of response behavior is very typical for each peer. So every peer gets different results. It's not very stable, and if you use this as a measurement how good a search engine is, then YaCy is really bad, because every peer it's a different result. But this is I don't think this is the right measurement. We also think about censoring. This is something which is really good in YaCy, because you can't do a global censoring. Mm-hmm. One peer can remove specific indexes, and we actually want that people want to clean up their index and take out something they don't want to have, because this is following a kind of wiki principle. Everyone can do a moderation, but nobody can apply a complete censoring of the whole index. So because every peer is an individual, because a person sits in front of it and does a moderation, it's different from all the other search engines.
So in other words, if I understood you correctly a second ago, if I attach to or I connect to one of the peers and say search for say FLOSS Weekly, I might get a different ordering of the results compared to, say, attaching to a different one that's even in the same peer-to-peer cluster?
Yes.
Okay, well, that's a quick answer to that. How is that useful? I don't understand why it would work that way.
It's actually useful because you want to change the search index. If the answer would be if every peer would create the same result as every other peer, then we would lose a lot of things like censoring resistance. Yes, if one peer removes one index, then every other one needs to remove it, and you cannot put in your own information from it. For example, you crawl your own web pages you are interested in, or put your bookmarks inside it and use your bookmarks as a start point. You actually want that it's different from all the other peers, because it's you who puts the target inside. What do you want to have as, what do you think is a good search result? You can influence this, and everyone should be able to influence this.
Okay.
But even it gets even more complex, because you can change the ranking. There are different ranking rules you can think of. Very simple rules are that you say, I want that the word I'm searching for appears in the headline. So this is a very simple ranking rule. It's probably not very good, but it's also not really bad. But other people can say, I want that it appears in the URL, or other one says, I don't care where it appears. I want to have something like a citation rank, which is similar to what Google calls PageRank. So we can do all of this, but you can combine them as well. And if you do a web search using your own ranking mechanism, then it's also applied to the remote peers. So they comply what you put in as your personal ranking wish to the search result.
Well, that's interesting.
We want that search results are different from every peer.
Cool. And so could I use this? Actually, I think this question came from the chat room earlier, but could I use this for, say, a site search for my own site? Like Stonehenge.com has 255 magazine articles that I've written over the years. Could I use this to basically provide a search for that as a web form that somebody could actually search my own site with this?
Yes, that's very easily done. And if you want this, then you probably don't want to have the search results from other peers. You don't want to have it getting a dirty result, because you don't want the information from others. So therefore, we thought that we call this a different kind of network, and it's a network where you are all alone. So you switch off in a different network mode, and you can run a site search, or what I like to call it, the most application of this is a project search. For example, if you have your own site, then it's mostly a mixture of maybe a wiki or web forums, and maybe in code repository and a bug tracker and so on. This is the most common combination of all the web systems that a project has. And you can put in all the information from all these different systems in one search index and provide the user a search result to all these different sources in your project. It's like a site search, but it's done for your own purpose from your own targets.
So sorry.
Yeah, it's easily to be done. It's the same as if you acquire data for the peer-to-peer web index. You just switch in a different mode, and then you have actually something which is kind of a search appliance, something you can buy as a product from companies, which is actually very expensive if you do this.
Cool. And so how does the cluster of machines decide who's going to crawl which sites, and how often do you recrawl a page, given that pages do change?
That's something everyone must decide for themselves. We don't want to order other peers to do something. If all the information which is inside of YaCy is done by the person who wanted to create a specific index, and this can be done with a web crawl. You can also read RSS feeds. You can read from other standards, like libraries have specific standards called OAI PMH, and so you can take the metadata from libraries all together in your own web index. We have some more methods to take data into it, and everything which is inside was taken by a person. It's not like a mechanism which orders all the participants to do something automatically. The second part of your question was how can you refresh the information? And this is also something you need to do. You can put in information once, but there's a scheduler inside. You can say, if I acquired an information once with a specific method, I want to run this method once every week. So you can refresh your index automatically.
Well, clearly you're not going to be able to crawl everything you've ever crawled once a week, because that's going to be a lot of crawling, right? So there must be some sort of, you have some sort of way of saying, well, crawl these more often than those, and these never change, or something adaptive that looks like that?
You can, of course, change the time. You can say, I want to acquire an RSS feed every 30 minutes.
Okay.
Or you can, every web crawl or every acquisition method we have can have an attachment of a process where you can say, I want to have it every month or every 4 months or so on. So
Cool.
this is very flexible.
Okay. What's this written in?
This is Java.
Oh,
Yeah,
all
can't
right,
you
well,
tell by all the Java books behind him there?
Yeah, I kept noticing that. Yes, there's a lot of Java books back there, including an O'Reilly Java book, I think. Yeah, look at
Yeah, I
that,
see a couple of O'Reilly Java books and some
Yep.
others, so that's good. That's funny.
For those of
There
you
we
not
go.
watching the video, we're actually staring
Java
at
in a nutshell.
shelf behind him. Yes.
Yeah.
Cool. And what? How do you test something like this? Do you have you have unit tests and everything for all the code you're writing?
No.
No, you're supposed to say, of course we do. Of course we do.
Yes,
No. If you're working with people who wants to do this because they have just fun with it, and I'm the maintainer, I care about what's inside of the code, and someone puts in something which doesn't work, then I write a mail and say, please have a look again. But I don't apply this to code style. If someone sends me some parts of code by email, and then I don't respond with, I cannot take your code until you put in a unit test. I just take the code, and I'm happy that it works. And if it doesn't work, I don't put it in the application. So we have a bug tracker. If something doesn't work, someone complies. But if you're working inside of a company, you can demand that you follow some programming guidelines. We don't have this. It's a little bit chaotic, but I think it wouldn't work in a different way.
Interesting. So there's a couple more questions that came in, some from the chat room. One was a little bit earlier about IP addresses. Do you need a static IP address? And I'm thinking, kind of to broaden this question out a little bit, what if you're going through, everyone has their own router, people are using internal IP addresses. Is it as simple as using port forwarding? Is there a specific port that you have to use? Maybe do a port forwarding in your router to get to the peer, one of the peers that you want to interface with?
Yes, that's a good question. I didn't want to explain it in the first place to didn't make it too complicated. Of course, if your peer wants to be, if you want your peer to be searched from the outside, you must put in port forwarding in your router. And mostly this is too complicated for the most people. If you know how file sharing works, then you know how to put in a port forwarding in your router. But we want to address more people, and who don't know so much about technology, and this is actually a very difficult point to explain this to everybody. But yes, if you want your peer to be visible from the outside, you must do the port forwarding. We have different naming for peers who participate in the network index. Peers who cannot be accessed from the outside are called junior peers. And peers with an open port to the outside, so they can be searched, are called senior peers. But there's not a restriction on junior peers. They can search as well, and if they acquire their own data, they can distribute their data to the other senior peers, which can then be searched from all the others. So they also, the junior peers participate in the acquisition of a search index, but it's not. It's better to turn it into a senior peer by opening the port.
Yeah, that's interesting. So in that case, when I wanted to use it, do a search, I would be accessing an external, one of the senior peers, an external URL to do that search, because obviously the junior peer is only going to have, the information that it has crawled. It's not going to get the whole distribution back from all the other peers, right?
You don't need to find the senior peers yourself. If you run YaCy on your own computer, then it finds those senior peers automatically. There's a network bootstrapping, and there's another peer type called a principal peer, and the principal peers propagate their list of peers they know to another position in the web. So, for example, an FTP upload, and these locations are then used for network bootstrapping. If you start YaCy, it loads these so-called seed lists, and once you have a list of senior peers, and these lists are lists of senior peers, then you can find the other new senior peers which come to the network very easily, because it's a process called a peer ping. Every minute, one peer makes a ping to another peer, and it's just to tell another peer in a network to tell them I'm alive, I'm here, I'm a new one, and the other peer stores this and returns a list of other latest peers which came to the network. So this information spawns very quickly without using these principal peer information. But there's a bootstrapping, it goes all automatically. You don't need to search yourself for senior peers.
So how, in that case, how well does this scale? Is there a scaling issue, or does it eventually break down, or can it scale infinitely?
It's supposed to scale infinitely. Because that's the construction of the distributed hash table. The distributed hash table means you don't need to access all the other peers, but just some specific peers to get a search result. But we have some gaps in the architecture. For example, if we would scale to 1 million peers, we would need to store the peer list in a different way. But that's just the detail. The search process is defined to scale infinitely.
So I was thinking about this, and I think you already answered this question, but I just want to make sure I'm thinking about running this on a Raspberry Pi, for example, because I'm into open hardware, and Raspberry Pi is small and cheap. You could set up a really big search engine using $25 Raspberry Pis, it sounds like. And my question is, the only problem with that is that the Raspberry Pi doesn't have much storage. So in that case, I could make the Raspberry Pi a junior peer, and it would only store, a certain amount of information. And then maybe there would be one big server who is the principal or the senior peer. Would that be feasible?
It would be nice if it is feasible. I have a Raspberry Pi of my own, and actually YaCy doesn't work very well on it because it needs too much memory. But because I like your idea, I wanted that it works this way, so I tried to make it possible on a Raspberry Pi, and I'm still working to find out where this memory issues are, so we can run it on a Raspberry Pi. It's not about the storage space; it's more about the RAM.
Right, right. I know you've got a lot of screenshots on the website, and maybe we can throw some of those up while we're finishing up, just so people that are watching the video can take a look and see what this. It looks actually really good. I mean, as far as the search engine, the configuration page has a lot of options, and then when there's a screenshot of the actual, what it looks like when you do a search. I mean, it looks basically like a Google search, which is great. It'll be familiar to people. A couple more questions while we're doing that. One is, does this search for documents and videos as well? Does it index those, or is it just the information that's on the web page? I'm thinking more for an intranet, a company that wants to deploy this. A lot of times they'll want to search SharePoint or a document repository. Will it work for that as well?
We can put in any type of documents into the search index. For specific document types, we cannot do a parsing of these documents, like movies and MP3s. MP3s could be moved because could be indexed with their meta tags, but unfortunately the meta tags are at the end of the file, and if we want to load this in a peer-to-peer network, then we would cause the peers to load all these MP3 files only to index the tags of the MP3. So we don't do this actually. There are more file types which we cannot index because there's not much indexable data inside. And what we do in all these cases is to index only the file name. So it can be searched, but only based on the data you have in the file name.
Right.
But we have some nice techniques to find out the entities inside of a file name, like for movie files, you know probably that there's a special way of writing file names, like a camel case, where you have an uppercase inside of the word. So we have a camel case parser to split file names into words and to put this into a searchable index. So this is possible. We use it this way. We also have a specific file search interface, which shows a search result in a different way than you know it from a web search, because it's not very applicable to this case. Maybe you want to see it in a different way, like in a table with the file size and with the date all in one row. And that's a special search interface, which is also inside of YaCy.
So do you have, this is a question that came up too, I think from the chat room, and also Randall and I have been going back and forth on this as well, do you have advanced search options similar to Google? Can I implement them right in the search bar? So can I do a minus, for example? I mean, I'm assuming you have like and or and things like that you would normally have, but do you also have like, I just want results from this specific site. I want to make sure that you don't give me any results that have this particular word, things like that?
Yes. We have the site operator. We have some more operators for search facets, which we provide. We actually show the sites in a sidebar. That's the place where I normally expect advertisements, but we have some search facets there, so we can restrict the search result to these facets. And one of these facets are sites. So you can click on the facet, and it actually puts in another option into your search request line saying site and then the host name. But you can also do a faceted search for file types, so you can restrict to PDF files. And YaCy reads also some information like the author name from the meta tag, and provides a search facet for authors, which doesn't work in the internet very well, because search engine optimizers put in rubbish there in the
Right.
author tag.
Right.
But if you're in an intranet, or if you do this for a company search, and you have nice tagged documents where the author is actually inside one of these meta tags, then you can have a search facet with these names.
Yeah.
Yes, we don't actually have the OR operator because it's. I think it's of no use.
Right, yeah, right. You wouldn't really need it. You just put both terms in, and of course, it comes up, right? So I got a couple more questions. First of all, who do you compete with? So who, maybe commercial or open source, whatever. Like, what are the other players in this space that you guys typically would count as your competitors?
This is not a commercial project. It's it turned out that there are now commercial applications, and I'm asked as a consultant to give some consultancy for some companies. So it turns out for me to be a little bit a commercial project, but we didn't define the project with a competition. With the competition idea, it started with an HTTP proxy I wanted to create, and what we can find a competitor. For example, the Google Search Appliance is a box you can rent and put into your own company. And I have some companies who asked me to support them to replace their Google search appliance with a YaCy peer. So, but this is not a competition I defined as a target,
Right.
but it just turns out that we can do this. We actually had a project where someone had the largest version of the Google search appliance for 10 million documents. And they wanted to have it replaced and made a project. So they defined all the data functionalities. We had a look what we needed to implement in YaCy so it can work exactly like a Google search appliance. And this project was successfully finished. And therefore, we know that we can do this. But it's not a target we define. We know we can do this. And as Randall said in the beginning of this conversation, there are some, I don't know if it was Randall, I'm sorry if I'm wrong. There are some companies which are not smaller size companies which cannot afford to buy some search technology. Mm-hmm. This would be a target. It's not a target to implement a YaCy search engine for such kind of companies, but it's not a business target. We just know we can do this, and people can use it in this way, and they don't need to rent a very expensive search appliance.
Right. So it sounds like at least, I mean, maybe the goal isn't to make money here, but it sounds like there is some money to be made in consulting work, right? Or do you offer a support model for people that want support for this after they've implemented it?
Yes, I'm working since more than 10 years as a freelance consultant, and in the last 2 or 3 years, people came and asked for consultancy for YaCy, and that's what I'm doing now. And this is actually a way to earn money for me, and partly I don't do this only. I also do some consultancy in search technology in general. But it's definitely a possibility to earn money, and therefore I now provide such kind of support models. I have a support proposition and a web page to present this. It's not on YaCy.net, it's on pro.yacy.net, mm-hmm. And where you can see this. But I didn't show this to you because it's all in German, and I didn't look for international customers at this time, but it's a service I provide. Yes. Are there any other? One last question from me, and then I'll let Randall finish up. Is there any other open source projects that are similar to this? Because this is something, for me at least, I know of some commercial options, but as far as open source offerings, this is something fairly new to me that I didn't realize that this was so fully functional. Are there any other open source projects working on this as well? Not at this scale. What we provide is very advanced, and I don't know many other projects which can be compared. But there is one project which is named if it's about search, and this is Solar. The Apache Solar project is an technology which provides a web API on top of the Lucene search technology. And for a long time, I thought this technology and YaCy competes in some way, but in 2 years ago, we implemented Solar as part of YaCy. So if you now are looking for a different option for search, then maybe people tell you to use Solar. But if you use YaCy, then you use Solar as well. We have the native Solar interface, which can be accessed from the outside as if you run Solar for themselves. So a real competition at this scale is not visible for me. Only in the business environment. There are business projects which can do partly more, like the Scandinavian FAST project, which was acquired by Microsoft. And FAST was written in Java and Perl, as I remember. But Microsoft is not really known to support these kind of languages very well. So this product is not used anymore because the customers don't trust that they get support in the future. But FAST would have been a different type of application which is similar to YaCy. And it was more advanced.
Just to clarify there, that's SOLR, solar?
SOLR.
Yeah, okay, good. We couldn't tell whether we were saying Zola or solar or whatever, so I thought I should probably ask about that. We're almost out of time. What's the roadmap look like? What features are you still missing, and what do you want help in making it better? What kind of people do you think you need for that?
There's at this time there's not a business roadmap. I have business customers who ask me to implement some features, and mostly I shouldn't talk about this now here, but some of them demand that it's then free software as well, so it will turn out somewhere. And a different roadmap is to support some of the other communities like Freifunk. There's a project which is called Freifunk, which creates a mesh network of Wi-Fi hotspots. So to support a kind of darknet of in a web. And there's also the Tor community. They want to have a search technology also inside their network. And they asked me if I can do something that it works inside their network as well. There are some small problems, but not big ones. So most things we do are coming from the communities, and you just need to turn to our webpage and our web forums and ask if someone can do something for them. And it will become a roadmap if it makes sense, and if there's someone who helps. And there's no actual roadmap in the web like in a wiki. No.
Okay, well that sounds like a good roadmap to me. Which is that there's no roadmap, which is even better. Which is that you're just going to go the direction it's going to go. So almost out of time, and I have to ask my two required questions. If you've heard the show before, you probably know what these are. What is your favorite scripting language?
I have to do some JavaScript sometimes because we need it in YaCy for the web application, but I don't really like it.
Okay. And your favorite text editor? It would be
text editor.
Yes.
I use Emacs.
Oh!
Yay! Finally, somebody said Emacs. Finally, for a change, I'm vindicated now. This is great. Yay! All right, thank you. The JavaScript question was a little toughy, but it's good that you use Emacs. That's nice. Thank you. Is there anything else we haven't covered? We talked a lot about everything that I think you wanted to cover, but is there anything that we haven't said yet that you want to make sure our audience is aware of?
No, we covered a lot of topics so far, and. I actually made a list, but most of these things are done.
Yeah, well, that's our job. Yeah, of course, we're supposed to go through the list. Yes. Anything else that you think we didn't cover yet that we need to talk about?
Of course, there's something I would like to say, but we need more help. We need more programmers to support us. But so I would like to ask for help.
Okay.
The best help you can provide is to have your own ideas and bring your own ideas and your own knowledge into the project.
Cool.
What we actually need to be more in the business, because you mentioned SharePoint. To replace something like SharePoint or the search functionality in SharePoint, we need an authorization component. We don't have an authorization component in YaCy, and that's something that has to do with LDAP requests, and we don't have enough knowledge about this. So if someone could do something about this and create an authorization component for YaCy, I would be really happy.
Well, there you go. So there's the call for request, call for help there. Michael, Kristen, thank you for coming on the show and talking about YaCy.
Thank you very much for inviting me, and it's a great honor.
Well, thank you. All right, thanks. That was Michael Kristen, who's talking to us about YaCy. What do you think, Aaron?
This is super interesting, and you can tell because we're kind of running late here. I had more questions I could have asked. I probably could have talked about this for a couple hours. You know, the elephant in the room that we didn't really mention, right, is with all this news about the NSA and Edward Snowden and all this stuff, right? I think that, you know, Tor is becoming more popular, even though they're having some issues. And you know, if you don't want your search results accessible by the NSA, go run YaCy and create your own search engine. I mean, that's the power of open source. You can go do this yourself. And it seems like they've really made an easy way for people to get started on this. I think it's perfect for corporate intranets, people that want to implement their own search, or for research, or for, you know, media indexing of sites. I mean, there's so many applications of this. And I feel embarrassed that I didn't know about it sooner. Also, I want to point out that if you go into they have a really cool visualization. We didn't really get into this, but if you go to their webpage, which is YaCy.net, and click on the join in, they've got a really good Vimeo video there that shows the visualization. You can see exactly where the peers are. It's very, very much like a Google plus Ripple's search when you do that. They got all the bubbles everywhere, and it kind of shows you.
Cool.
And that's on the join in page from the home page. They've got a really nice video there that you can go look at. It's really, really cool. So they show you all kinds of, you know, here's when we were talking about the junior peers and the senior peers and the principal peers, you know, it shows all that stuff, and it's so cool. So we didn't get a chance to talk about that, but I wanted to point it out to people. So if you're watching, you're seeing video of that right now. Very cool stuff. So yeah, I mean, you know, especially I think if you can get this running on commodity, you know, more commodity hardware. I mean, memory's not that expensive, but again, it just seems like a perfect fit for a $25 Raspberry Pi, or even the $35 Raspberry Pi that has a little bit more memory. You know, you combine about, you know, 100 or 1,000 of those, and all of a sudden you have this super distributed network that's hopefully hard for people to take down. It's always up. It's not searchable by anybody else but the people that use it. Anyway, I could go on and on. I think it's great.
Yeah, and I know he didn't exactly say that as well, but you know, you could participate in the network even just by running this, so that you're actually helping to crawl pages and be a service provider for other people. So this would be a great thing to do if you just wanted to, if you had some spare hardware sitting around and you didn't have anything else to do with it. You could just run YaCy in the background and be part of a way to have something besides the big search engines to contribute to other people. So it sounds pretty cool.
Absolutely.
Very good. So, upcoming guests, that's our awkward transition of the week. Not very awkward, actually. I just simply read the line that was below it under the previous line on my outline here. We've got Wireshark coming up next week. Wireshark is amazing. It's used to be called Ethereal. It's the wire protocol analyzer. So, in other words, everything goes over TCP/IP or even UDP, has some sort of protocol, and this thing knows how to dissect all those protocols and figure out exactly what's actually happening. So you can watch a web conversation happening in real time and stuff, or you can record a bunch of stuff and then play it back later and see if there was an intrusion and that sort of stuff. It's really kind of cool. We're getting the actual creator of Wireshark coming on to talk about it. We've also got BeagleBoard coming up. Aaron, you want to talk about BeagleBoard for a second?
Yeah, sure. So BeagleBoard is very similar to Raspberry Pi or Arduino. It's a small little embedded Linux computer, basically, that you can use for all sorts of things. And it has pins on it, and you can hook up LEDs and all kinds of cool stuff. So it's basically a little processor. You program it. You say, I want to go run this robot. You hook it up, and the robot goes. It's really cool. So if you're familiar with Raspberry Pi, or if you're familiar with Arduino, those projects tend to get more attention. You definitely want to check this out. It's going to be right up your alley.
Sounds like fun. And after that, we have QGIS, QGIS, I guess. I don't know how to pronounce it, except pronouncing all the letters, I guess. That'll work, which is a desktop geographic information system. So be able to visualize maps of things and allocate nodes to the maps, things like that. GPotter, which some of you may actually be listening to this show on. It's a podcast manager, an open source podcast manager, been around for a long time. And then for the last one we have scheduled so far, we're still trying to fill out the rest of Q4, but the last one we have scheduled so far is Crossroads, which is a fork of ZeroMQ. We've had ZeroMQ on the show before, Peter Hingens himself, but we're going to talk to one of his former coworkers who forked ZeroMQ, and we'll ask him why he forked it. We're still continuing to fill in the rest of Q4. You can go to twit.tv/floss and look at the big spreadsheet, see who's actually coming up on the show. You can follow us on Floss Weekly on Google+. You can also follow at Floss Weekly on Twitter. We do have a live chat. We did take some of the questions from the chat room today, and that's at live.twit.tv. We tape typically 8:30 a.m. Pacific time Wednesday, which seems ungodly early today for some reason for today. But and you can follow me at Merlin, Merlyn, on Twitter. I'm also on Google Plus at Randall L. Schwartz. I think that's everything I want to plug for now. What about you, Aaron? What do you want to plug today?
So a couple of things. Number one is, I don't know if you saw that Valve released Steam OS, right, along with a couple other things, some machines to run it on. It's going to be running on Linux. I would love to get someone from Valve on the show. Don't know if you're open to that, Randall. I'll just put you on the spot right now.
Yeah, there we go. Yes, sure, why not?
But the way this works, and Randall's mentioned this lots of times on the show, is that we need our audience to find out who the project manager is, and then get us that person. So instead of having an intermediary, we get right to the source, so to speak. So if just an open call out to anybody that maybe knows somebody at Valve, or maybe they have a head of Linux engineering or project manager of SteamOS that we could talk to, please get them in touch with us. Let us know their name so that we can get in contact with them. I'd love to get them on the show, because I think again, much like Android, this is a very important supporter of Linux and open source that we could talk to, and I think it would be really interesting for everybody. So that's my call out to you. One more thing, it was good to talk to at least one person at Oracle Open World last week. It was very busy, but I had one person come over from Java 1 and say, oh, I'm a big fan, how you doing, can I get your autograph, all this stuff. So I always love doing that, regardless of whether they ask for an autograph. I think that's silly, but it was really fun to talk to that guy. I'm sorry I can't remember your name. I know you work for the government, but it was really fun to talk to you. He's a big fan, and so thanks for that. It was a lot of fun meeting you there, as well as a big fan of the show, and a union guy that I got to talk to in line while I was waiting for the appreciation concert. He's like, oh, I know Twit. I do all this professional sound work, but I know about what Twit's doing. So this is kind of cool to talk to him as well. So I think his name was, well, I won't use his name just in case he doesn't want me to use it. If you want to follow me, you can follow me on Google Plus. Just add me to your circles. That's where I spend most of my time, almost all my time, on Google Plus. But I also broadcast out to Twitter and Facebook. If you want to follow me there, you can as well. If you're watching us live, be sure to stay tuned. If there was tuning anymore, I guess it still exists. To this network, I'll be on This Week in Google coming up at 1 o'clock. So you can catch me there. It'll be a lot of fun to be on Twig again.
Yeah, well, I still call this taping the show, so it's
Right.
Shows my anachronism for that. But I always tweet this as I'm taping the show today or whatever. But it's what tape? There's no tape involved. It's all
Right.
disc now. It's all
Yeah, we say like, don't touch that dial. Nobody has dials anymore,
Yeah,
right? I
dials.
mean, what
Yeah,
are you talking
really.
about, dial? What's a dial?
Or even like you dial a phone. I mean, it's like there hasn't been
Yeah.
a dial on phones for decades.
Right,
So
right.
there we go. It's all crazy that way. But anyway, that's enough of that. Like we say every time around this time of day this week.
At the end of the show, we always
I'm
say.
going back to bed. I'm going back to bed right after this show. But we'll see you all again next time on Floss Weekly.